Okay. I hope you guys are doing okay in your exams. Silence. That means you're not doing okay. Okay. So, last time, we actually finished pointers. We have been discussing pointers for 4 lectures. Today is the last big topic in C. Right? And these are structures. So one thing that is very important in C when comparing it with other languages is actually C is not an object-oriented programming language. What do we mean by this? For those who knows what is object-oriented programming, it's a methodology, if you would say, it's a methodology of programming where you can structure your code in a certain way. Good? Let's put it in this way, and when we come into Java, we'll talk about this in more details. But the thing that you need to know from now is C is not an object-oriented programming. It's not designed from the beginning to be an OOB language. Good? But the problem is, so far, all the topics we discussed, including even pointers, we didn't have a way of defining one entity that includes multiple types. What do I mean by this? Assume we are here at the university. We want to build our software system that includes all the information about each student in each year. What year are you in? When are you supposed to graduate? What courses did you take so far? What courses are you still need to take to get graduated? All this information about one student. Good? And then we have a database of all this information about all students. If you look into the basic entity of this database, it will be one student and all the information about the student, right? But this information is not of the same type. Right? So, for example, your personal information like date of birth is date type, your name is a string, what courses did you take can be an array, what courses are you going to take, maybe another array. So we have so much different or variety of data types inside this entity. And the way you should structure database is this has to be one entity, because once you enter the ID or the name of the student, this is how things work in reality, right? You get all the information about this student. So far we cannot do this, even including pointers, because the best thing a pointer can give you is a contiguous area in memory that can have multiple types, that's true, but you don't link these types together. You cannot call all of them using a single ID or a single name, right? How to do this? Today we are going to see how to do this using what we call structures. You can look into structures as an early or maybe a preliminary way from C to emulate as if you have an OOB, as if you have an object-oriented programming or classes. We will see later in Java that classes do the job for all of this. This entity of a student, you need it to be one thing, which we call a class, for example, a class of information, right? A student is a class, a professor is a class, a course is a class, and you connect these things together. Good? So in C, because we don't have classes, you can do this using structures. Good? So you can look into structures as your early step to know what is OOB. Good? Okay, so I already gave you this motivation. One, yeah. What was your question? If you are in the picture, you get the consequence? Oh, now, no, it's over. Maybe we'll give, like, I'll try to do this later again, but for now, like, this was the quiz of the last lecture. Right? Okay. So, a motivational example of structures. We want, for example, we want to write a math program for monomials. What is a monomial? It's a very basic information. You have something like one single term where you have a coefficient and then a variable that has a power. this is called monomial. If you have multiples of these added together, then you have a polynomial, right? Very basic high school math. So we want to define such monomial. Again, so far, we cannot do this in C, because you cannot define a pointer, an array, or something that has both coefficient and power, and the problem is coefficients can be floating point, but power is integer. So these are two different types. Good? So we're going to do this using structures. The way to define a very basic structure in C is you write the reserved word struct, and you define inside this struct multiple types. One can be float, which is the coefficient, the other one is integer, which is the power, and then you name these structures mono 1, right? Something like this. And then later, if you want to assign values to these things, the way you access the elements of a structure using the dot operator. Good? So you'd say mono 1 dot coefficient is going to go, mono 1 is going to go to this entity in the memory, and coefficient is dot coefficient, which is this element, and then you assign point 3. Good? We already discussed this. And let's see how to initialize structures or define them in multiple ways. So one way to initialize a structure, so we already discussed one way, which is you define the structure and later you initialize it, element by element. But another way would be, when you are defining your structure, you initialize the elements. And the way to do this is equal, and then you put the values in the order. So that means the first one will go to the first element, the second one will go to the second element. So the order here is important. Good? So you define your elements, and then you write their initialization one by one. Good? So this is the second time, I guess the second time that the order matters when we program C. What was the first time for a bonus mark? When the order will matter in your code. When you write, when you do multiple things, and then their order will matter, aside from using a variable before initializing it and this basic thing. I'm talking about one type or one methodology of programming in C. Initializing an array. Yes, but I'm talking about something that is more complex than this. Initializing arrays is very clear, right? Yeah. Yeah, in the function, like passing parameters to a function, right? In the function, nothing is telling you that this mapping, like assume you have a function that has 10 input parameters. Good? When you call this function, you have nothing at all that tells you you are passing this element to this element, like A to X and B to Y, right? You don't write such code. How the compiler will understand that you are passing this element to this input, this passing parameter to this input, using the order. So the first element in the caller has to be to the first element in the function prototype, the second element to the second element, etc., etc. Right? Here is exactly the same thing. Initializing the first element, the second element, and you go forward. Right? Then what if I want to initialize another thing? What if I want to have another monomial? Then do I define another structure, say struct, coefficient, power, and then mono, like 2.3, 10? Right? You can do this, but then you are not leveraging the full power of a structure. What I mean by here is, assume I have my math program that I'm writing has like hundreds of monomials, right? Or even I want to add these things together to have a polynomial. Each time I need a monomial, I'm going to define a monomial with a coefficient and power and then initialize it? No. Right? What I'm going to do is define my structure as a data type, put it aside, and then each time you can have another version of this data type or have a copy of this data type. You will deal with the structures as if they are integers or arrays or doubles or something of that sort, right? But by doing this, we are going to define our own data type, because your monomial structure is not something that is already defined in C. How would you tell? So, in other words, if you want to define an integer variable, just write int x, right? But assume I want to use my structure as a data type, and then this is called mono 1. Can I say mono 1x? No, because this is not a predefined data type. You have to do one extra step, which is telling the C compiler that I'm going to use this structure as a data type and then have multiple variables of it. Good? So how to do this? Instead of defining two different structures, you say, I define a structure that I call monomial, and then say, instead of just writing this thing, at the end of the structure, this is the way you define your structure as a data type, and then say struct monomial. When you write your C code, now you can say struct monomial mono1, and then this is a variable that is called mono1, that is a version of monomial. And then you can just directly initialize it. If you want mono2, then you do the same thing. This is a good way because now you don't need to write two definitions. You just write one and then keep copying it. Keep having multiple versions or multiple variables out of it. But it's still an elementary way of doing things. This is not the object-oriented way. Each time I need to write struct monomial, right? You just don't write monomial mono1. And then one extra thing that C gives you is what we call type def. Type def is a predefined word, reserved word in C, that you are telling the compiler, now I want to define a type. So you just don't define a structure, you define a structure and you tell the C compiler that this is going to be a type that I can use later. How this will be helpful, right? So instead of doing this, and then each time write struct monomial mono1, struct monomial mono2, 100, etc., then you just say, like maybe at the beginning of your program, type def struct monomial, and you call this some name, monom, or even monomial1 or something of that sort. This is telling you that monom is going to be of a type monomial. And then the C compiler will know that if you write monom x1, then this is a variable of this type, and then you can initialize it. Good? Another easier way of doing this is when you define the structure itself, you just say type def struct, you put the variables of the struct or the input entities inside the struct, and then you give the struct name, and by now you can just say monom mono1, monom mono2, etc. I give you multiple ways, but this is the easiest and most elegant way of defining a structure as a data type in C. So if you guys get confused in early slides, this is the thing that you should be doing in your programming. And let's take this step by step and let me know if you have a question. First of all, type def is telling the compiler that you're going to use this structure as a type, as a data type, like it's an integer, it's a double, right? So this allows you to write this line later, good? And then struct, because here you are defining a structure, and then this is the name of the structure. Inside the structure, you can have elements of any type, arrays, integers, doubles, pointers, good? Another structure inside a structure. So this is the good thing here. If we go back to our student example, if you define a structure of student, you can have here a string or an array of characters that is the name, and then another string which should be the date of birth, for example, which here is in the student, and then courses, did he take it as an array, and then maybe you also have a definition or a variable of another structure that include another information, right? Like what professor do teach to this student, or what are the marks of his exam in past years, something of that sort. So you keep organizing your code in a certain way. Good? Okay. So let's move forward with this way of writing things. Now if you define a variable that is called mono1, and this is something that is important, I guess people get confused with. What is the difference between mono1 and the structure monomial itself? Mono1 is just a variable out of this structure. So what happens behind the scene is if you define this structure, it gets allocated in the memory, and then the compiler will know that this is a type. Each time you define a new variable out of this structure, as if you take a copy, and then you replicate it in the memory, and then you work in this copy. Good? This is why you can have multiple things. You can have mono 1, 100, millions, it doesn't matter. You can define any number of variables out of this type. Do you have any question? This is another way of thinking, like, so the things that I spend more time in are the lectures that define you a new way of programming. Like it's another way of thinking about things. And you need to change your mind to be flexible to use this thing. So when you think in a problem, oh, this is suitable for a pointer, this is suitable for a structure. This is why introducing the new concept is very important. So if you get confused, ask questions, and then later it will be easier. Is there any question? Yeah. Yes. Yeah, yeah. So the structure, once you just define mono1 as a variable out of structure, it knows that these two items together, right? So it knows that a structure is a place in memory that holds multiple data types. What are the types that are within this structure is when you define them. So the C compiler will know once it finds the structure, it knows that it has two elements. The first one is float, the second one is int, and it behaves accordingly. So this is an agreement between you and the C compiler that this is my structure, this is the number of elements it has, each type is so and so, right? So it will not get confused. And this is the way you deal with multiple types inside one entity. Okay? I asked you before the question of can we define an array of multiple types? And we said no, right? You cannot have one array that one entity is a float, the other one is integer, etc., etc. But now we can indirectly do this. How we do this? You define your array entry as a structure that has multiple types, and then because a structure now became a type, you can actually have arrays of structures, right? So array that has 100 elements, each one of them is a structure, and then inside the structure you have float and int, right? And we will see this later. Right. So here, how to access the elements of the structure. Mono1 dot power, again the dot operator is the thing that gives you the, how would you call this, a member. Like power is a member of the structure monomial, right? So this is the member operator. So power is a member of the structure mono, and then mono1 dot power will give you the value of power. Plus plus something, you can do any math operation in this, because basically for the compiler, this is at the end an integer variable that you can do all math operations on the integer variable, right? Good. The other thing is you can access elements of a structure using other operator than the dot operator, and this happens when you define a pointer to a structure. Again, a structure is nothing now other than a normal data type that you define yourself as if it's an integer or float. And from our previous lectures, everything adds up. You can have a pointer to an integer, right? A pointer to a float. With the same concept, you can have a pointer to a structure, right? And then here we are defining a pointer, and this is pointing to a structure that is called monom. Good? And then what I'm doing here is taking the address of this monom1. So what happens in memory is once you define this mono1 using this line, it reserves a place in memory that has a float and an integer. And this is mono1. Good? Now what you are doing is taking the address of this mono1, which is here, and place this in the pointer. Right? So now pointer, BTR, is going to point to the structure mono1. Right? So if you do this, you can access the elements of this structure, or now of this pointer, using another operator, which is called like the pointer operator, a structure pointer operator. And later in classes we'll see the same thing. So this is like this, like dash, larger than thing. This arrow, it's completely equivalent to the dot. But when you use the dot, when you use the arrow, use the dot if you are accessing the structure itself. Use the arrow if you are accessing the structure through a pointer. Right? So here, BTR is pointing to this. I want to access BTR coefficient, which is my float. Then you use this pointer operator. Good? As you can see, this is completely equivalent if you say mono1 dot coefficient. right? Both give you the same thing. Is there any question? Okay. So because this is at the end is a float variable, you can do any math operation like doing pre-decrement in this variable, right? So now you are subtracting 1 from the coefficient. You can do anything basically. Okay. What it says here is these two operators have the highest precedence, which means if you have them in one expression, these things will be executed first before addition, subtraction, or anything. Okay. Is there any question? Now comes another topic, which is a structure. Again, it's just a data type. We can pass data types to functions. Then we can pass structures to functions, right? Another thing that is actually very useful for structures is we said you cannot return an array from a function unless you return a pointer to this array, right? But you can return a structure from a function because for us, array is not a data type, but structure is a data type. Right? So here, we are going to pass a structure to a function. So what we do in the main is we define, this is our already defined structure. And by the way, you have to do this before, it's like all the rules apply for defining a variable. You have to define the variable before using it. And because for you, monom is a data type, you cannot use this data type without defining it as a structure. That's why people usually define structures as global before the main, right? I told you before that global variables are not allowed into SH4, except for structures, because you want to use structures as within the main and other functions as well. Good? Great. So here we defined our structure, which we have seen before. Here we initialize multiple variables of this structure, mono 1, 2, 3. We initialize mono 1 with 0.34, which means the coefficient of mono 1 would be 0.3. The power of mono 1 would be 4. Okay. So then what I want to do is define or prototype a function that takes these two monomials, these two structures as an input, and then multiply the monomial together. So if you have 3x to the power 2 and then 0.5x to the power 5, you want to multiply these things together. Now you're doing some math operation on a monomial, right? How to multiply two monomials? Can someone say? You multiply the coefficients and then you add the power, right? It's basic math. So this is what we want to do in the product function. But the important thing is, as you can see, the product function is taking mono 1 and mono 2 as if they are completely normal variables, right? X and Y. So how do we define this thing? This is a prototype. Again, you use monom as if it's an int, as if it's a data type. And then you call mono A and mono B, these are your input parameters. Inside the body of the function itself, what you do is I'm multiplying the coefficients together, mono A and mono B, and then I'm adding the power together, and then I'm returning a structure here. Can someone see something that is problematic here for a bonus mark? What is the problem with this function? Yeah? Yeah, but I'm taking them as an input. So you don't need to initialize, right? Yeah? Yeah, I'm rewriting mono A, which mono A is, at the end is mono 1. So that means I'm changing mono 1. Right? Yeah?
When you return mono A and mono 3 is going to be the same as mono A or mono 1 then, so when you modify mono 3, that also reflects mono 1.
Yeah, which is very similar to what he said, is once you change, because you changed mono A, you are also changing mono 1, right?
When you like assign to mono 3.
Mono 3 will have also the multiplication, like if mono 1 is changed, that means mono 1 and mono 3 are equal. This is what you are saying, right? Yeah. So this depends on the fact, mono 3 for sure will hold mono A because you returned it. But the point is, am I changing mono 1 or not? Did I have to define a new variable here? And the thing is, no. Structures, similar to all other data types we have seen before other than arrays, they are passed by value by default, right? So they don't get changed. So it's, even if you change them here, this change will not reflect in the main. And this is very important, right? Structures, once you deal with them as completely normal data types, then they are just a normal data type. Think of, when you get confused when writing a code, think of a structure as if it's an int data type, right? So if we have seen before that things get passed to the function by default as by value. If you change them inside the function, they will not reflect in the main. You remember this? The same thing applies to structures. But then my question is, what if I want intentionally to change these? What should I do? Yeah? Yeah, pass pointers to them, not the structure itself. Similar to, you want to change an integer variable, you pass it by reference by passing a pointer to its memory location, right? Good. And this is what we do here. We call this function product by reference, and instead of just passing the structure itself, we pass the address to the structure. And then inside the function, we define a pointer to the structure rather than just defining the structure itself. What is the difference between this one and the previous slide? These two input parameters are pointers to the structure variables, not the structure variables themselves. Which is, in other words, you are passing these structures by reference, right? Good? Now, what I'm doing inside this thing here, we call this dereferencing in pointers. You guys are experts in this term now. That by doing dereferencing, you are just taking the structure itself, and then you can access this using the pointer, can access this using the member operator, right? Or the structure member operator. Can I write this in a different way? Yeah? Using the arrow thing, but what do I need to change then? Yeah, you don't need dereferencing right now because you want to access the pointer itself, right? So we can write this in this way. Instead of doing dereferencing and then doing dot, this is a pointer to a structure, which means you can access the elements of the structure using the arrow operator, right? So these two are completely equivalent. These two are completely equivalent. I don't know why you guys are loud today. This side, like. Good. Is there any question? Yeah.
Can you do that arrow reference with anything besides structures?
No. Why? Because you mean a pointer to something other than structures, right? Structures is the only entity we have so far, or only data type that has members, right? Remember, the arrow and the dot is just like a member operator, which means I'm going to this structure, but go to a certain member. If you have a pointer to an integer, it's just an integer. It's like 4 bytes of one int. You cannot have a member inside an integer, right? Wait. So far, this is doing some operations on members of a structure, which at the end are either integers, float, double, something that we already know. What if I want to do math operations on a structure itself? Everything we cover so far, we see if we can do some arithmetic operations on, right? In pointers, we said you can do some pointer arithmetic on a pointer. In arrays, we said we cannot do math operations on the array as a whole, right? What about structures? The only thing you can do of structure is you can assign a structure to a structure, right? So you can say you define your student structure, and then you have student A. You can say student B equals student A. What will happen? Can someone imagine what will happen behind the scene? Assume this student has, maybe we go back to our mono examples. You can see. Here, I have two members. If I say mono 1 here, if I say mono 2 equal mono 1, what will happen? What does it even mean? Should I say it's a bonus mark? You guys, it's an easy question, so it doesn't need to be a bonus mark to answer. Guys, come on. Yeah? But what is the value of a structure? You have multiple things inside a structure. Yeah? That's a good question, right? This is why I'm asking what will happen if we do this. If we say mono 2 equal mono 1. I'm saying this is a valid operation. Good. So to answer your question, it's a valid operation. You can say mono 2 equal mono 1. But something has to be logical behind the scene to allow this operation, right? As you said, when you define like a structure of this type, it has to take two inputs, this one and this one. So if I assign to it a structure of the same type, and I'm saying this is valid, how do you think this is valid? Like, what will happen to make it valid? There is a step that is happening by the compiler that we don't need to care about. So let's start from the point that she said is, or if you define mono 2, that means you need two input values, one for the coefficient, the other one for the power, right? By doing mono 2 equal mono 1, how to get these two values? You take them from mono 1, right? Like that means this is equivalent. If you say mono 2 equal mono 1, this is completely equivalent to say mono 2 dot coefficient equal mono 1 dot coefficient, mono 2 dot power equal mono 2 dot power, right? But because inside a structure you can have thousands or millions of members, doing this is very time consuming, right? So the C language allows you to do this by default, just taking a complete structure and then say this is equal to another complete structure, and then everything get copied just for you behind the scene, right? But there is one constraint here for these two structures. To be able to copy all the elements, what should happen? They have to be of the same type, right? You cannot copy a structure that has 10 members to a structure that has just 2 members, right? So both mono 1 and mono 2 has to be of a type monon. If I define another complete like structure that I call like student, the one that we discussed, you cannot copy a structure student to a structure monon because these are two completely different things. So when the compiler tries, or the hardware tries to take a member to a member, a member to a member, this is not one-to-one mapping. And even the types may not be the same, right? So the only thing that you need to do for this assignment thing is you have to assign a structure to another structure of the same type, right? This is very logical, I guess. Right? And then another thing, we have already seen this, is to take the address of a structure using the AND operator, right? And then size of, I told you before that size of function operates on data types. You can say size of float. And we have seen this in malloc function, when you allocate memory for like an array of floating points, right? So for us, now structure is nothing other than a data type, and then you can say size of a structure. What will happen, what will come back to you, is the size in the memory allocated to the whole structure. For example, for our structure thing, here let's say the float is just 4 bytes, good? That means you have 4 bytes for coefficient, 4 bytes for power. That means your full structure is 8 bytes. When you say size of monon, it should give you the summation of all the size of its own members, right? So here, size of monon should give you 8 bytes, right? Why this is important? Because we used this before. What if I want to dynamically allocate a memory for an array of structures, right? Something you cannot do in C is to compare structures. You cannot say structure 1 is less than or larger than or equal to structure 1 because it has inside members. So what does it mean to compare something like a structure larger than another structure? It has no meaning to say a student is larger than a student. Maybe the grades are larger, the age is less, but not the whole student itself, right? Good. Here, this is giving us the trick of defining a structure inside a structure. I told you, you can have elements or members of any type, including even another structure, right? What we do here, we define a structure that we call date, has day, month, year, and then defining another structure that is student. Inside it, you need the birthday of this student, which happens to be a variable of type date, which is another structure you define for yourself, right? So this is how you define a structure inside a structure. You just use it as if you are defining a structure or instantiating a structure inside the main, for example, right? Good. I told you that you can define a structure inside a structure, then you would ask yourself, can I define a structure of my own inside my own structure? This cannot happen because now you are referencing to yourself. But if you want to do this, you can do another trick, which is already in the slide. You need to instantiate a pointer version of the structure inside your own. And this thing you can do. Here, assume I want to define a variable that is also of type student. But I said you cannot do this because you cannot refer to yourself. Can you think of why I cannot actually refer to myself? Yeah? Exactly. You are calling a structure before it gets defined, right? But here, you are defining a pointer, right? And then a pointer doesn't need to get an address at the beginning. You can say this is a pointer of this type, and that's it. Later, you would say that pointer equal to like some variable, right? So if you want to point yourself as a structure, you need to use pointers, right? This is a very important concept when we come to object-oriented programming in Java, right? What if you have a class and then you want another version of the class itself, right? So this is one of the most important applications of a pointer, right? Okay, another thing is arrays of structures. Again, everything we discuss in this lecture will come from your mind that a structure is nothing other than a data type, right? We can have arrays of any type, floats, integers. We can have arrays of structure. Good. How we do this? We already defined our structure, and then exactly the same way you define an array by writing the data type at the beginning, and then the array. The only difference is when you initialize this, you need to initialize all the members of the structure. Think of this, if you define this poly thing. It has 3 elements, right? But inside each element, you actually have 2 things, right? One is the coefficient, the other one is the power. So inside each entry of the array, this is poly 0, 1, 2, right? So this one is a structure which has 2 members, so when you initialize it, this will go to the coefficient, this will go to the power, etc., etc., etc. Right? Is there any question? Okay. And then how to access the elements? One array element is just a structure. You access exactly the same way you access structure using the dot operator, right? And you can think of all messy things. You can actually have a pointer to this array that happens to be a pointer to a structure element, and then you can use the arrow operator, right? So you can combine arrays, structures, pointers, and even pass this to a function. Things can get really complex, right? Yeah. What will happen for this line? And this may be a bonus mark. If I print this after writing this code, what will happen? What do you expect to see as an output? A new face? Someone from the back? Yeah? I told you that you need these bonus marks, right? If you don't believe me, I guess the midterm is coming and you'll see. Yeah. Negative 1.2 and 9. That's true. Thank you so much. Please give me your name afterwards. Right? So bully is an array. I said 1,000 times before that the array name is a pointer to the first element, right? So this is completely equivalent to say bully 0. And bully 0 is a structure that has these 2 members. So its coefficient is 1.2 or minus 1.2. And then poly plus 1 is, this is a pointer arithmetic, which is accessing the first element after like poly 1, right? And then it gives you the power, which is 9 here. Okay? Okay. So dynamic memory allocation, and we conclude by this. So to combine arrays and then malloc with structures. I define my structure, and this may be a structure for an employee that has its own name, which is a string, with array of characters, and a salary, which is like an integer variable. And then I call this employee. Now I want to define or to allocate an array of pointers to this. You remember we had this example last time when we had this. Each one of this was pointing to another array, right? So array of pointers to another array. Good? So what I'm doing here is I'm initializing 10 locations in the memory. Each one of them is the size of what is employee asterisk thing? It's a pointer to this structure, right? So this is allocating 10 elements of an array. Each one of them is a pointer. This is why we have the double asterisk here, because the array name will be a pointer to pointer, right? So like the what we called last time double pointer. And then after defining this line is allocating this thing. Each one of them is a pointer to. Now we need to do this. Which is initializing the other array that is here, right? Which is size of employee. Each one of them happens to be only one structure. I can have this also as an array, but now it has only one element. And I'm assigning the pointer to this structure to the first element of the array, right? And then I can ask the user to input the name and the salary of each employee, right? What we are doing here, as if you are building a database that is dynamic enough, that takes all the employees in your company. So as a user, maybe you enter first of all the number of employees, which you use as a programmer to initialize everything, to allocate in the memory the storage you need, and then later you ask the user to input the information for each employee, like the name and the salary, name and salary. And then what you need to do is to assign the name and the salary for each entry in the array. Like you will keep doing this through a for loop, right? Which is this one. B0 will take the name and then the salary, the second one, the second one, the second one, right? As you can see from this example, we started our, I'm not sure if this was our first quiz or second quiz, by just second quiz, by simply just asking the user to input 20 integers and store this as an array, right? This was like a very basic example. Now, you can ask the user to input any number, not just 20 elements, and not just of the same type. Here we have name, which is string, and salary, which is int. You can generalize this to be of anything, right? How to think in these things, this is very important. You need to define what is your use case. Now, your program is completely built on the entity of an employee. It has two members, right? And then how to build the data structure is another thing. Just the picture that I have drawn, right? This is even before you start programming. And this is the way you should approach the lab or any program you write, right? You should think of what is the use case, what are the things, maybe you need to write an equation, maybe you need to draw a picture, and then you take it step by step to program. The last thing you need to do is start implementing, right? After knowing exactly what you're going to do. Some of you may go to the lab, start writing code, delete it, or discover you have a problem and then you debug it, or when you look into the output, it doesn't match, then you write things from the beginning. This is not the right way to approach programming, right? You should first know what is the algorithm, what you should do. You have like a picture in your mind to implement, and then start coding this. This will save you like tons of hours in programming if you have a big project. Good? So by this we finish, and let's continue next lecture. Thank you so much. Yeah.
When you're working with structures, at the very end you said reduce the size of. So what does that do? So does it store memory first for the structure, and every time you initialize a member of that structure, it will allocate the same amount of memory?
The same amount. Like your question is, so I would say this. The right way to ask your question is, what happens when you instantiate a variable of this structure? Does it write to the same memory location or does it copy it, right?
Yeah.
It's another version, so it copy it to another base of memory, which is, assume the monom thing example we had, right? Monom is get allocated in the memory as of this thing. When you define mono 1, you allocate another place in memory that has both coefficient and utility. The size of will give you the type, like the,
How much memory time?
yeah, which is the same for every variable, right?
Yeah, I understand. But then, like, is there a pointer to point at each one?
Yeah, if you say,
No, I mean, going back to the employees.
yeah,
When you have, let's say, when you first define employees, it stores that many. And then let's say you want 20 employees. So does it store an array of pointers to each one?
to each one. This is what we have done in this example. Okay? To be able to access them.
Programming was on paper.
Yeah,
But it's probably running on
yeah, you're right. I don't see another way of doing it. Yeah, sure.